Yes, we served up to number 21. Tell me if you wanna solve the problem from number 22. Uh, yeah, geometry. Yep, let's look at number 22. Let me see. Yep, so in this example, there are three spheres in the base of a cone. So let's make the three spheres. They are tangent to each other. So if we connect the center of each sphere, we will have this equilateral triangle. And we don't know the radius of this sphere, so that means the side length of this equilateral triangle will be 2r, 2 times r. And then the center of the base circle will be located in the centroid of this equilateral triangle. So if the side length of uh, the triangle is 2r, this line is called the median, and this is a special type of right triangle. So half of the side length is r, and using Pythagorean theorem, the length of the median is r times the square root of 3. And then the centroid is divides this median with a ratio of 2 to 1. That means this length from the vertex to the centroid, the length will be uh, 2/3, 2/3 of the median length. And then this view we are looking at these three spheres from the top, and let's change the view, the sideways. Uh, that means if we look at this circular cone from the side, they will have this this type. This the side of the circular cone looks like this equilateral isosceles triangle, and I'm looking at one of the sphere located here, and let's find out the center of this sphere. I'm going to use the coordinate like this. So the center of the circular cone, this point is at the origin here, and so this length is equal to this, because from the center to the center of each sphere, uh, that's the distance from this vertex to the centroid. So that means the center of the sphere in this case is x coordinate is this, and the y coordinate is this one, just r. And then using this slant height, we can find the equation of this line. It has the base radius is 5, so the x-intercept is 5, and height is 12, so y-intercept is 12. In this case, the equation of this line is x over 5 plus y over 12 is equal to 1. And then, because this sphere is tangent to this slant height, from this center to the line, the length, the distance will be the same as the radius of the sphere. So this distance is also r. So we can make the equation. There is a formula to find the distance from a point to the line. So let me introduce the formula. So if the point is x0 and y0, and if we want to find the distance from this point to the line's equation, let's say this is the line's equation. In this case, the formula is the distance from the center to a line is this. And so it's like we are putting this point to this line, and that makes the part of the formula. So I'm going to use this formula. So the point is the center of the sphere, and the line's equation is this. So if we use this formula, and the distance in this case, this r, the radius of the sphere, and I'm going to put this coordinate to the value of x and y. Oh, this is 3. So that makes something like this. And in this case, because the center is located below this line, actually this value is negative. So in this case, when you open this absolute value sign, the numerator is negative, so we can change this r to minus r. And then the bottom is 13. So we can multiply 13 to each side. And if we solve this for r, we can divide both the sides by this one. So at first, let's divide both the numerator and denominator by 2. And then we can rationalize the denominator by multiplying 9 minus 4 times square root of 3. and the denominator will be 81 minus 48, which is 33. So we can simplify this by dividing 3. Yep, so this is the value of r, the radius of the circle. Yep, so from the choices, which one is the same as this value? When you open the parenthesis, the numerator is 90 minus 40 times square root of 3 divided by 11. So, yep, so b has the denominator of 11, so the answer is b. Yep, yeah, tell me another problem you wanna look. 23, yep, yes, yep, I think I copied this. Yep, so let's just start with a number which has the uh, number of divisor just one. The only number uh, which has one divisor is 1. So let's just start with 1. So if we apply this function to number 1, this function makes the twice the number of divisor. So 1 times 2 is 2, and number 2 has two divisors, 1 and 2. So if we apply the function again, the twice 2 times 2 is 4, and number of divisor of 4 is 3, 1 to 4. So multiplying 2 makes 6. How many divisors does 6 have? Yep. Yeah, 4. So after applying one more function, it becomes 8. And 8 also has the 4 number of divisor, 1 to 4, 8. And now the problem is, after applying this function again, it still is 8, because 8 number of divisor for 8 is 4, so it ends up with 8. But we want to find the number which ends up with 12 instead of 8. So this number 1 is not the case we want. So let's start with any number, I mean, in of which the number of divisor is 2. That means actually prime number. So uh, we are starting from 2. The number of divisor, number of factor is 2. So in such case, we follow the same pattern. If we start with 2, we will have 4, 6, 8. It ends up with 8. So this one also we don't want. This case we don't want. And let's say the number of factor is 3. In such case, 3 times 2 is 6. But the problem is 6 is here. So the next one will make 8, and it ends up with 8. So this one also we don't want. And 4, if the number of factor is 4, 4 is here, so it ends up with 8. And if the number of factor is 5, 5 become 10. How many factors does number 10 have? Yep. Yeah, you're 4. So the problem is if the number of factors is 4, that makes 8. No, no, sorry. Yeah, yeah, that makes 8, right? 4 times 2 is 8. So it ends up with 8. So this one is also not what we want. So, and if the number of factors is 6, 6 times 2 is 12. How many factors does 12 have? Yep, that means number of factors is 6, right? Now 6 times 2 makes 12. So after it reaches 12, it remains as 12. So that's the case we want. We want to find the numbers which makes the functional value 12. So this is an example of the number we want. And let's say the number of factors is 7. 7 times 2 is 14. And how many factors does 14 have? 4. So 4 times 2 is 8, and 8 it ends up with 8. So this one dismissed. And if the number of a factor is 8, 8 times 2 is 16. How many factors does number 16 have? Yeah. 5. So 5 times 2 is 10, but the problem is when it comes to 10, it ends up with 8. So not you want. And if the number of a factor is 9, 9 times 2 is 18. How many factors does 18 have? 6. So now 6 times 2 is 12. And after we reach 12, it remains with 12. So that's the case we want. And finally, let's say the number of factor is 10. So 10 times 2 is 20. And how many factors does 20 have? Yeah, you're right. For 5. Yep, so number of factor is 6. That's the case we want because 6 times 2 is 12, and after it reaches 12, it remains with 12. So I mean, we wanna find the numbers up to 50. So I think the maximum number of factors is about 10. I mean, there are 3 cases we want, and we wanna find each case. So let's say we wanna find at first the number having the number of a factor is 6. That means one case is 2 to the 5th power. This one has the number of factors 6. There are 6 factors in 2 to the 5th power. And another case is because 6 is 3 times 2. We can think of this type of a number. The number of a factor is the product of 1 plus this exponent. So because 6 is 3 times 2, the exponent is like 2 and 1. Because 2 plus 1 is 3, 1 plus 1 is 2. Yep. And then so we can think of other factors. Instead of 3, the prime factor is 5, like this. Uh, that's the maximum number we can find because the number should be below less than or equal to 50. We cannot make 13 times 4. Or if we start with the 3 squared, 3 squared times 2, 3 squared times 7 is not possible. And how about this one we can make? So these are the numbers having the number of a factor 6, and to have a number of a factor 9, because 9 is 3 times 3, we can think of this way. That's one case, and I don't think other numbers are possible below 50. And the number of if the number of a factor is 10, because 10 is 5 times 2, 5 times 2. We can think of this number that makes 5 times 2, and I don't think other cases are possible less than or equal to 50. So how many numbers did we find? Yep, how many numbers? 10. Yep, so the answer is D. Yep, 10. Yep. Yep, 20 and 24 and 25. Oh, okay. Yep, sure. Yes. So in this case, I'm going to use red color for 0. That is red for 0, and blue for 1. And in this case, each face should have the number 2. That means there should be uh, 2 blue lines and 2 red lines to make each face. That's the meaning of 2 in this case. So let's say the 2 lines are parallel. So we can think of this type of face. So it has 2 zeros and 2 ones, so that makes the sum is 2. And then for the front face, let's try to make this one also parallel to the other. In such case, because each face should have 2 blue lines and 2 red lines, uh, it must have the front line must have this shape. And then for the right face, because it already has 2 blue lines, the rest should be 2 red lines. And for the rear side, the backside already has 2 red lines, so we need to make these 2 blue lines like this. But now we have the problem because the left side already has these 3 blue lines. That means we cannot make 3 red lines parallel. So we should go back. So instead of these three red lines parallel, we need to make one red line perpendicular to the other. So let's say we make oh let's say we make this red line, and by making this red line, the front face should have two blue lines like this. And for the left side already has two blue lines, so the rest should be two red lines like this. And then for the back side, it has already two blue lines, so it should have two. It already has two red lines, so it should have two blue lines. And finally, for the right side, it has two blue lines, so the rest should have one red line. So this is one example we want. So in this case, we have these two parallel sides. So because this cube is made of the six pairs of parallel lines, we can make this type of cube uh, six ways, because there are six pairs of parallel lines. Yes. So that's one example. And another case is, now let's start with not parallel sides. That means we want to make this type of top face instead of a parallel red line. Let's say we start with this perpendicular the red lines. That means uh, the rest should be blue line for the top face. So now top face looks like this. And then because we don't want to make the parallel red lines, we can make this way. Now all three lines are red lines are perpendicular. In such case, for the right side, we have this blue line. We fill these blue lines, and then because we don't want to make any parallel lines, we can also make this one to perpendicular. In such case, the rest is blue line for the front face, and then for the left side, it is two red lines hidden. And then for the back side, it has two red line and one blue line, so another hidden line should be blue. So we can make this type of example. Now all red lines or all blue lines are not parallel, and the property of this one is that for the corner, for the corner, uh, the uh, blue all blue lines starts from one corner, and these corners are diagonal. And in the case of a cube, this type of diagonal, we can make four cases, because the cube contains a number of vertices. The diagonal pairs we make four. So the total case is 6 plus 4, and then we can exchange this blue and red. So for each case, we make the pairs. So that means it's like sum of 6 plus 4 times 2, because we can exchange blue and red. So yep, what's the number? Uh, 20? Yep, so the answer is E. Yep. How about number 25? you wanna serve this one, or you are okay with this? Oh, okay. Let's just see. Yeah, let's just sit together. Yeah. Yeah, last five problems actually are difficult. So yeah, so we are starting with the quadratic polynomial. Let's say the p of x, the polynomial, has two solutions like this. Because the leading coefficient is 1. And then if we composite two this function twice, so p of x means, so that means this one. And if we open the parenthesis, p of x looks like this. So if we change p of x to this expression, we have this expression, and when this is equal to 0, and this polynomial is disrespectful, if it has exactly three real numbers, so that means one of these parentheses has double root. So for example, if this has one solution and this has two solutions, and they will have three different solutions. So let's say the first parenthesis have double roots. Having double root means the discriminant is 0. So if we use the discriminant for the first parenthesis, this should be 0 to have one root. In this case, the one root means double root. So if we solve this equation by opening perfect square, let's see. Okay. We can solve this equation for beta. Yep, so we can make another perfect square like this. Yep, so this is the equation for the relationship between the two roots, alpha and beta. And then we want to find the sum of the roots is maximized. So that means we want to make the alpha plus beta as great as possible. So let's say sum of alpha and beta is k, for example. And we can change beta to this expression, and in this case, we wanna make the sum maximum. We don't have to use this minus sign. We can assume that beta is alpha plus 2 times the square root of minus alpha. So if we use the expression, k is 2 alpha plus 2 times the square root of minus alpha. And let's say this square root of minus alpha is p. In such case, minus alpha is p squared. So if we change this alpha to p, k is equal to minus p squared 2p squared and 2 times p, and then we can make the perfect square to find the maximum value. Something like this. So that means when p is 1/2, the k, the sum of alpha and beta, will have the maximum value. So if p is 1/2, alpha is minus 1/4, and beta is here. Beta is 3/4, and so now we have this equation having the sum of root maximized. Using alpha and beta, we have this expression. And finally, we want to find this p of 1. So when x is 1 in this function, 1 plus 1/4 is 5/4. 1 minus 1/4. Yep, so what's the product of these two fractions? Yep, so that means the answer is A. Yep. Yep. Yeah, that was wow, 2021 fall. So yeah, let's move test B.